Cool. Evening, everyone. Thank you so much for giving it your evening to come and listen to me and others. I didn't get the fancy dress memo. So I'm sorry, but yeah, I wasn't told. But yeah, I'm here to talk a bit about JavaScript testing. That's me on Twitter, and you can find more stuff from there. So I want to really split this talk into 4 bits. Why do we even bother testing? How to test, common kind of gotchas or mistakes you may be making in your test code base, and then a little bit at the end about testing React specifically, because I heard that a few of you have used it before. Thought it'd be worth mentioning. Actually, a previous talk, Marcel's talk, already covered testing and hinted at it, which is really good, so he set me up very nicely. So I want to talk a bit about why we even bother testing in the first place, when we have such a rock-solid language, system, build chain, when all that is in such a state it's in, why we even bother writing tests in the first place, and why, as a group of people at an advanced React meetup, we even need to bother. Maybe it's just me, but I make quite a lot of mistakes, and I've found tests have caught me many times, which has proven very useful. When I talk about tests, one thing that always seems to be very divisive is this idea of TDD, or test-driven development. You'll find these people who say that you should always write your test first. All your code should be test-driven. You'll get these other people who say, no, I never write my test first. I just write the code, and it works, and then I write some tests. And you get a lot of articles like Stack Overflow posts, there we go, Twitter chains, all about like, should you write tests first, what's the right approach, and so on. I think really my answer is really the cop-out, the sit-on-the-fence answer of it depends. It's really a running theme of most of my talks. But I think there are some situations where TDD lends itself really well and others where it doesn't. So I work at a company called Threads. We're an online men's fashion startup. It's where Marcel got his outfit from, actually. He wasn't even sponsored, it just happened that way. And yeah, we sell clothes. So let's say you come to work one day and your colleague says, we need a function to talk to our API for finding items within a certain price range. So I need to be able to call this function, tell it the minimum price and the maximum price, and it should get me back items that are in that price range. Here is a really good case for going test first. The reason being that you've got to effectively come up with this API, and right now you don't really know what it needs to be. So by writing your test first, you can decide on a certain implementation. So maybe I sit down and I kind of, without thinking, just write the first thing that comes into my head. And this is my first test. And the important line is this line. This is my item finder. This is the bit that I'm writing. This is the function I need to complete. And I've decided one API that could work is you call .min and give it the minimum amount in pence. I'm not incredibly rich. That's the pence numbers. And you give it the maximum amount as well, and it returns you items. You might love that API. You might dislike that API. It doesn't really matter. The point is you wrote a test, and it came up with one, and then it got you thinking, like, is this really what I want? Is this the best implementation? And you can just quickly go through lots more in your head. There's loads you could do here. You can type them out. You can get the code working. And now you've just kind of immediately got your head thinking about what API feels right. By immediately using the thing you're about to build, you can have more confidence that you're building a thing that you're going to actually enjoy using and not come back to in 6 months and be pretty frustrated by. So this is, I think, an area where test-driven development really shines. It lets you test an API before you actually use it and kind of battle test it a little bit. That's not to say that by writing the test first, you'll then come up with the perfect API and never change it, but it's kind of guided you in a direction where you didn't really have too much to go on before. But I think there are times where test-driven development is bad as well, so that's why you'll find me sat firmly on the fence. Sometimes you don't actually know what the API needs to be or what it needs to do yet. So you get asked again, please write a function to talk to our API that gets items for the browse page, and this is the browse page, is grids and grids of items that hopefully you go on to buy. And this is quite a kind of open-ended request, right? A function to talk to the API that gets items. But gets items how? Do we need to filter them? Like here, we're just looking at shirts. How does this actually work? So if you sit down to write the test for this yet, you don't actually know what you're going to write. You can't fill in this string with something descriptive. And you'll end up writing tests that guess. And I've done this. When I first kind of read this whole TDD mantra and I got really into it, I thought I'd please people online by doing it religiously. I found that I'd write tests and then just delete them because it turned out I didn't even need that test. The thing didn't have to do that. I'd effectively write 10 tests. Maybe 2 of them would be stuff I kept at the end. The other 8 would have been me guessing and guessing incorrectly. So you're better off here actually writing the actual code and implementing it. So I fire up my editor, I load up some React. I actually don't know what font this is, I'm sorry. And it turns out after all the writing that I end up calling this items finder thing, and we need to pass in the number of items we want and just the minimum price, and that's all we need. Now I've done this, I can go back, or there it is, there's me calling it, and I can go back and I can write the actual 2 tests that I need. So I've saved myself lots of guesswork and writing tests that I'm never going to complete, and now I've got very good descriptive tests that outline all the functionality that's required. Again, Marcel hinted at this earlier, tests are a really good way to fix code, fix bugs rather, for good. Let's say there's a bug where price filtering by maximum price isn't working properly. So we can sit down, we can prove it in a failing test. We say we've got some items, the price is £30, and if I call it with a maximum price of £20, we shouldn't get that item back. And then your test runs, you get a big red error in your terminal, expected empty array got the array of items. And this is really good because we've recreated and isolated the bug now. And what's also nice about this is if you've got the test running like when you're changing files, either in like the VS Code terminal or a separate terminal or kind of whichever setup suits you, you should now be able to work on it without having to like wait for the browser to refresh, wait for Webpack to build, go make a coffee every 5 minutes, and then come around and click around the 4 buttons you need to recreate this bug. Instead, you've just got a test that recreates it straight away, and it should be really fast to run through. I feel at my most productive when I've got a failing test, and I've got my editor and my terminal side by side, and every time I hit save, the test reruns, I know how I'm doing. So you can fix the bug without changing the test. It's important here that you don't change the test, because that's what's proving that you're fixing the bug. You rerun the test, and now you're all set. What's really nice about this is you fix the bug, which is great, but you've also ensured this particular bug can never come back ever again, because you have a test in place saying that it can't. So not only do you get some productivity hits, or benefits rather right now, but you and your colleagues now have a bug that you can never introduce again. Once you have this suite of tests, it lets you refactor really confidently as well. Types go along with this really nicely as a kind of boost to refactoring. There's a kind of cycle that you should go through when refactoring. It's called red, green, refactor. So the first step is you write the test and you see it fail. This is you implementing new features. We're going TDD here. We know exactly what's required. We write whatever code it takes to make it pass. And this can be the hackiest code you've ever written. It can be really dreadful. It can do all sorts of weird stuff. It doesn't matter as long as it gets your test suite passing. All we're trying to do now is turn the test from red to green. And we can then rewrite the code until you're happy using the test to guide you. Because once you've got it working and you have that green tick in your terminal, you can refactor this as many times as you want, and you'll know immediately if it's working or if it's broken. So tests let you rewrite, they let you tweak and refactor with a really quick feedback loop. You don't have to wait endlessly for browsers, and you check that everything is working as you expect. So that's why we test. Now I'm going to move on a little bit to talk about how to test. This isn't too React specific. There are some mentions of React throughout, but hopefully if you might not be using React every day or using a few different things, a lot of this should apply across whichever framework you choose. It's important, generally, I think we would all agree that your application code is well written and maintainable, but you can put up with rough edges, particularly if you've got a good test and you've got good coverage of tests. But remember, you don't write tests for your tests. And that means that your test code has to be extra good. It's harder to have really hard to debug tests because you don't have tests helping you debug the tests. But you could write tests for your tests, but then, of course, you're going to need tests to test those tests, to test the tests, and then really we're just getting a bit silly. So what makes a really good unit test? I think there are kind of 4 important aspects to this. The first is the description. It clearly says in the string at the top what's being tested. I should say as well, all my examples are using the framework called Jest, which is another Facebook invention. But these kind of, across all test frameworks, will look pretty similar. So you should be able to adapt this to your preference. The first line, we should set up the test. Make any fake data, mock anything out, which we'll come on to. We should then call the actual function we're testing, and then assert on those results. So I think a pretty good test looks something like this. So we go back to our item finder again. So our description, it returns the right set of items, and that's pretty kind of easy. It's also good that these strings are reasonably short, as much as anything, just so they don't wrap around lots in your editor on small screens. We then do our setup. The setup here is we need an array of some fake items for our test. So we do the setup. We then call the function under test, which is the item finder function. So we call that, passing in the right arguments and our fake data that we just set up. And then we make our assertion or our expectation. And we expect that the result equals whatever we need it to equal. A really good way to think about this is you should be able to look at a single it test and know everything about that test. So if we go back to this one, We know the data that we're testing on, we know the function we're calling with what arguments, and we know what our expectation is, all in one little block of code. Here's, I went diving into the thread code base. Shockingly, we don't get it right all the time, and found a less good test. So we've got a little helper function we wrote called getCookie, which reads in cookies. I'm pretty sure we all probably have one or have installed a similar thing from NPM. So we're saying result equals getCookie foo, and we're expecting that equals bar. And if you're looking at this for the first time, or maybe there's a bug in the cookie library and you're kind of driving in, trying to fix it, you come across this test, you should be a bit confused, because it's not that well written. And the main question you should be asking is, well, why does getting cookie with foo give me the string bar? That's not here. Nowhere is that mentioned or set up. If you expand and look up the whole file, you scroll up to the top, you see right at the top, and there's more tests than this one, so in reality you would have more than 5 lines, so you wouldn't just casually ignore the top 2. We see that we're setting document.cookie to equal foo equals bar, which then makes this test run correctly. A quick way we can improve this test is just to pull that assignment down into the it. And now you've got everything you need in one place. Another good rule of thumb is that tests should have no external dependencies, especially as front-end developers building web applications. I think the main one that is kind of relatable to all of us is network requests. I'm sure you've got React components or JavaScript that makes requests to GraphQL APIs or REST APIs, or maybe some of you have SOAP APIs. And you might write tests that say it fetches the 5 items from our API. We have this fetch items function that just goes off to our API and pulls down the items. So you write this test, and it connects to your real API, and it returns 5 items. And then one day, one of those horrible back-end engineers who thinks they know best does a git commit. Make items API return 10, not 5 items. And now the front-end test suite is failing without you having to change any of the code in the front-end test suite. If you find that your tests are failing because of completely unrelated changes, maybe even changes in a different code base or an entirely different part of the application, that's probably a sign that your test isn't well isolated enough. It's got an external dependency that is controlling if it passes or fails. This is just going to cause you lots of pain when tests fail randomly and it takes you ages to debug why. You can use a few different approaches to this. There's a library I like to use called fetchmock, which does exactly what you think. It replaces the fetch API in test with a fake version, and you can stub it. So you can say like fetchmock.get/items, and it's going to go and look out for any request to /items and fake that response that you give it. So that's very useful. Often there's a slightly cleaner alternative, though, in the form of spies and mocks. I want to kind of caveat myself here by saying that there's a lot of overloaded terminology in, well, in development, as I'm sure you're aware, but in testing as well. You'll find spies called spies, stubs, mocks, fakes, doubles. There's a lot of terms. I'm pretty sure I'm using them all incorrectly, so I'm really sorry about that. I tend to mix and match, but I'm going to stick with spies and mocks. So spying is that we can spy on a function and know if it's been called, and we can use that to help test. And mocking is we can take a function and replace it with a completely different implementation just for the purposes of test. Let's see how that actually kind of works in practice. So let's say we've got an item sorter function, and this fetches items from our API, and then it sorts them in some way. I don't know, maybe by price or by ID or by color. I don't know, whatever. It sorts them somehow. And we want to test that. We want to test that given these items from our API, it sorts them in the order we expect. So we start writing our test, and we call await item sorter. But this is going to make a network request. And in this case, we're testing that given a set of items, it sorts them in the right way. So we're going to want to make sure we control which items are being returned. So to mock, we can fake a function's implementation just for the purpose of a test. And again, my code for the mocks is using Jest, which has a really good mocking support built in. Most of the other test frameworks do, or there's popular kind of third-party alternatives. They will all look mostly similar, but with subtle differences. So if you're not using Jest, you will still be able to replicate all this functionality. You just might have to look up the docs slightly for how. So using Jest, we can import our item fetcher, and we call this jest.mock line, which kind of does all the magic, and lets us replace it with a fake implementation of the module. So you'll see here I'm using the mock resolved value call down here. And what that lets me do is say to Jest, hey, when I call item fetcher in this test, don't actually call it, but instead return a promise that will resolve with this data. So it's a really handy way to fake out an asynchronous call that's going to fetch some data. And now, because we're in complete control of this data, we can say that it's going to return an array where the first thing is a shirt and so on. We can write our tests properly. You should be careful with mocks, though. They give you a lot of power, but you can definitely go overboard with them. And I think the only way to learn this is to actually do it and feel the pain of doing it. But you'll find if you mock too much, the implementation of a function might change from how you're mocking it in your test, and then suddenly your test will pass, but your actual code is failing because the implementation is different. So you do have to be slightly careful when you use mocks and consider that they are a bit of a cost that you're taking on. So just kind of don't go overboard with them. It's very easy when you first use them to really dive in, but you only need them in certain situations. So that's the first two. I want to talk a bit more now about kind of common mistakes you might see in tests, or ones that I've come across. And I don't want this to sound like I'm kind of lecturing. These are all common mistakes because I know they're common because I've made them for the past 10 years or so. So common mistakes you might come across in tests. Most frameworks, including Jest, will allow you to define a function called before each. It might just be called before or before every. The name might differ slightly. This is a function that you can call that will give you an easy way to run a certain bit of code before every single test runs in your code base. So it's a great way to run code before each test. And this is really handy if you've got some common setups. So say you've got like 10 tests and they all need the user to be logged in for this test to work. In a before each block, you could write the code that makes the user be logged in for the purposes of those tests. And that's pretty useful. But it can also make a test hard to work with or debug. And we've seen this before already with the cookie example earlier. But when you're setting up stuff in a before each, it can lead to tests being hard to kind of figure, and especially know where items are coming from. So in this case, literally, the items variable isn't defined here. Again, in a very small test suite, in example slides, this doesn't seem like a big deal. But when you've got a lot of tests and they're a big, long file and you're on your laptop, it can be very hard to find where a source of some data is coming from. If we scroll right up to the top of this test, we'd find a before each that configures the items. It's really tempting to do this, and I've done this many times, because if you have lots of tests like this, where you've got const items equals and you define it, and say this test suite has 10, 15 of these it calls in, and you're defining the same items over and over again, it's really tempting to pull them up into a before each. It's actually something we've been taught kind of ever since you start learning to code, this do not repeat itself, this dry, like get rid of duplication. This may be slightly controversial, but I think in tests, duplication is actually pretty good. I think I'd much rather have all the data next to each test than duplicate it across a big test suite in a before each. And we'll look at other ways you can kind of make the pain of having the same data in lots of places easier in a bit too. So keep the test setup close to the test. And this is about the third time I've mentioned it. I think it's one of the most kind of important things you can do to keep your test code base readable and usable. You've got to remember, a lot of the times you'll be diving into test is because there's a bug that you're trying to figure out or reproduce. And so you're likely going to be a bit frustrated, or maybe there'll be a bit of time pressure on fixing this bug before a big launch or something. So keeping your tests kind of usable, and you can dive into a big file and find just this and understand it all at a quick glance is really, really valuable. You also want to try and avoid testing internal details rather than an external API. If you don't do this, you're going to end up with tests that are really, really brittle. So if we take a look at this test that has two assertions using my shirt finder class that finds all shirts with a maximum price of £50. There are two, let's say this is expected to return nothing for the purpose of this test. It's actually a really badly worded test, which I'll try and pass off as purpose for the point of an example. But anyway, there are two ways we could make the expectation here. We could say shirtfinder.__found shirts, which is some internal value, is an empty array. Or we could say get shirts equals an empty array. If you were consuming this API for real in your React component, you'd almost certainly use the latter one. You'd use get shirts. And you should be using that for your tests as well. Your tests otherwise will end up being really brittle. Let's say I wrote this shirt finder, and you think my implementation is pretty bad, which is a fair bet. And so you think, I'm going to refactor this code and show Jack how it's really done. So you come in and you refactor, and in the process of refactoring, you get rid of this __found shirts variable. Maybe you rename it. Maybe you actually use the new private fields implementation, proposally babbly thing, and you get rid of this entirely. Now your tests are breaking. Your tests are breaking all because you reached into a thing and pulled out some internal stuff that isn't part of the public API that this thing exposes. However, if my test didn't do this and it used the getShirts function, nothing will have broken because the test is using the same public API that your React components and the rest of your code base will use. So you should be able to rewrite code, your implementation code, without changing all your tests. If you don't do this, you're just going to hate testing, because all that's going to happen is every time you change any minuscule detail or implementation of any of your code, you're just going to have loads of test break for kind of seemingly pointless reasons. People who kind of talk about how they find tests not very useful, or they harm their productivity, or they're too slow to work with, typically are because they're not testing the public API and they're instead keep reaching in for internal details. So I talked earlier about how, especially when it comes to data for tests, you shouldn't avoid duplication. You should have the duplication in each test. But now you're thinking, well, if I've got 10 tests that each set up an array of items and then something changes, that's going to be a pain to change in 10 tests. And you just told me that tests shouldn't be brittle. Coming up with a structure for consistent test data is a really important way that can help you here. You'll probably find, depending on kind of where you work and what your product or what you're building is, you'll probably have a few objects that pop up lots. At Thread, we sell clothes, we call them items. So you'll find a lot of the JavaScript tests in the Thread code base deal with items, either an array of items or fetching items or showing an item. We have this item that pops up all over the place. So you go through our code base and you search for dummy item, you're going to find a lot of declarations. And so we've set up our dummy items, and then one day we ship a new feature. All items returned from the API will have a new property called button type. I'm sure there are a few of you who are more fashionable than me. I didn't know until I joined a fashion company that there are a lot of different button types. Honestly, the amount that we think we know about clothes and that we actually have on clothes, honestly, it's mind-blowing. There are like 29 different collar types. You know, just happens to. I thought that was interesting. Anyway, so our API is now returning button type. We have to update all our front-end tests to include this button type variable so that our test data is in line with our real-life data. There are a few kind of ways you can solve this. You can also generate test data from APIs, particularly if you have schemas, like GraphQL schema, say. But one way we've done it is by using what's called factories. And factories are effectively ways in a test code base to generate fake data. It's a shameless plug because we use a library that I wrote. It's really good. It's called Test Data Bot. And its job is to generate you fake data for your test. But crucially, fake data that looks pretty realistic, or at least semi-realistic. Yeah, as I said, don't know if I mentioned, it's really good. So in our code base, we have what's called an item builder. And this builds us items. And what you do is all these functions like fake and array of are coming from the Test Data Bot library. What you do is you tell it what fields you want and what they should be. So you see right at the top, I'm saying the brand should be, and we use fake, calls the faker library, which is just a thing that generates fake, like realistic data. So we generate a fake company name. And for color, we generate a random color. Then for images, we generate an array of fake image URLs. Is thread own brand is a Boolean that can be true or false, for example. Sentiment, so you can like and dislike items on thread. So we say, okay, if we've got this fake item, its sentiment can be neutral, positive, or negative, and so on. So we have this defined in one place in our code base. And any test will import it from our factories file. And so if I just want a dummy item with semi-realistic fake data, and I don't care what it is, I can just call item builder, and I get one. Let's say for a particular reason you need to define the name for this dummy item, but you want everything else to be fake and random. You can pass in the name. This will generate an item that's got faked, random everything else, but it has the name Oxford shirt. And now if we go back to adding button type to an API, all I have to do is go into my item builder factory and add one line that says button type, and it will probably be like a random string, or we'll give it one of the 20,000 different button types there are, and it will just generate them for us. And now all our tests have real data. So we found this really, really useful. I should, more seriously, there are other alternative libraries available alongside Test Data Bot. There are a bunch of them out there, and you should just find one that works for you, but it'll probably be Test Data Bot. Okay. So another kind of common mistake that will cause you a lot of debugging pain later down the line is failing to keep your tests isolated. Can anyone spot the subtle problem with these tests? Yes, thank you. I heard someone shout it. There's a subtle thing here, which is both these tests are testing on a logged in user, but you'll see there's only one call to log user in, and it's up here in the top one. What this means in reality is this test will pass only if it runs after the first test. Now, actually, most of the time that will be true. I think Jest does that. It will run them in order, I think. I'm not 100% sure. But most test frameworks will either run them in a random order every time to help you avoid this problem, or you can pass a flag that lets them run it in an arbitrary order. There's a couple of ways to solve this problem. Again, if we go back to being explicit in our tests and doing all the setup properly, the fix here is to call logged in user every single time. This is also important because one of the things that all the test frameworks will let you do is run just one test. Say you've got a file with 20 tests in and only one of them is broken. It's kind of annoying you've got like 19 successful tests in your console and one broken one. What you can do is you can ingest, you would put an F at the beginning of this to make it say fit for focused it, and that will only run that one test. So it's quite useful for zoning in on the test you want to do. You can also do it.only if you don't like fit. My top tip with that, though, is there's an ESLint plugin for Jest that will error when you have got fit or it.only. I learned about this after I pushed a focus test to production, and for 4 months we ran one test in our whole application. It never failed, but yeah, we're running one of about 800 tests for a good few months, and so now I have the ESLint rule in place. And this kind of stuff, logged in user, it also applies to any mocks. You're mocking out functions. Make sure that you clear them between each test. And Jest and all libraries have functions that just, you can call them and they will clear stuff out, or you can configure Jest to ditch all the mocks between each test run. Another mistake is when you write a test, not actually checking that it fails. This sounds really weird, but there's a problem with this test. Anyone spot what it is? Yeah, there's no assertion in this test. Some test frameworks will fail here. Other test frameworks treat no failed assertions as a pass. So if you run this test, Jest will actually say it's passed, which is pretty brilliant. You can pat yourself on the back and move on. But many test frameworks will actually pass a test that doesn't have an assertion. Or if you're testing asynchronous code, the asynchronous expectation will happen after the test run has finished, so you can miss it as well. There's a few ways you can get around this other than like being a proper developer and writing expectations. But most frameworks let you call a function to tell it how many test expectations you're expecting. That's a lot of expectings. But anyway, if you call this, Jest will know that you're expecting to call expect twice. This is a very confusing sentence. You're expecting to call expect twice within the one test. And if you don't call expect twice like Jest is expecting, it will fail for you. I didn't even practice that. It was off the cuff. So if you write a test for testing some code and it passes, be very suspicious. Try and break it. Like, deliberately write incorrect stuff and make sure you see it fail. I'm going a little over, but we'll whiz through a little bit of testing React. First, this wouldn't be a talk at a meetup of mine without a shameless plug. I did a whole video course on testing React applications. It's bright yellow, just make sure you're awake. And you can buy it. You can go and buy it online. How cool is that? So if you go to javascriptplayground.com/testing-react-enzyme-jest, you'll find a link in the navigation as well. The first 5 videos are actually entirely free on YouTube. You can go and watch them straight away. If you want to get the rest, you can pay a small fee of $20, I think. But if you lob Advanced React in at checkout, you might get a little discount on that as well. I don't know if I'm biased or not, but I highly recommend doing that. Cool. So there are 2 main frameworks for testing React. Marcel used Enzyme earlier, which is also mine of choice. There's also another one called React Testing Library by a guy called Kent C. Dodds. He doesn't really do much, so you probably haven't heard of him. I personally use Enzyme. I've used Enzyme for years. So my examples are in Enzyme. A lot of people are loving React Testing Library, so I'm not here saying like Enzyme is way better. I'd say check them out and see which one you like. I want to talk a bit about how we kind of define a React test. If we're writing tests that test behavior, so here I render our cookie notice component, which shows that nice we use cookies. And when I click the close icon, I expect it to go away. These are actually closer to what I would call integration tests rather than unit tests, because we kind of got all this code that's powering that cookie banner, and we're checking that it's all working together. So the way I think about tests in our front-end React code base is we have unit tests, which are the ones I've used throughout this talk, like the shirt finder finds shirts. We have integration tests, which is when I click on this button, the thing goes away or stuff happens. So really, just kind of a bit of context on how we do it. We split our front-end tests into 3 parts. Unit tests on our plain JS. I think like hipsters would call that vanilla JS. We have integration tests on React components. And then we use a thing called Cypress to write end-to-end tests. If you ever used Selenium and wrote it off because it was horrible and your tests failed all the time, I don't know if that was just me, Cypress is far superior. It's pretty cool, and I'd highly recommend checking it out. I've been burnt a lot with end-to-end tests and losing days debugging them. Cypress is really cool. So how do we actually test our React components in our code base? First, consider, do we actually even need to test React components? For simple components, maybe they're just like you've got a component that renders a close button. You might not even need to bother. Like really, if they're that straightforward, you might not need to. And so we lean towards plain JavaScript tests whenever possible. My one bit of advice, if you take one thing away about testing React specifically, is to test the component as the user. So here we have a button component. I was really proud of that one. I came up with that in Starbucks earlier, and honestly, I was waiting for the applause. There are 2 ways we could test. Thank you. Yeah. That was really pathetic, isn't it? I have to beg for applause on stage. Anyway, there are 2 tests we could write here to test this button component. There's the top one. Using Enzyme, we mount the button, we click it, and we read the state from the component. Or the second one, where we simulate the click, and we look now to see that the button is disabled. And hopefully, given my earlier kind of mention of not testing internal details, you realize that the latter is much more superior here. The first one reaches in the component to get some state. This one is going to break even if you rename the isDisabled state to something else. That's going to break the test, and that's just frustrating. The second one won't, because the second one is actually testing what the user would see, the disabled button. Incidentally, one of the reasons people like React testing library is because it only lets you write the second kind of test. It doesn't give you this way to read internal state. I'm going to whiz through these. Mocks are really useful for React tests. They're a really good way to ensure that you kind of don't waste time like setting up things in your components. You just mock the stuff you need. And finally, Jest lets you test with a thing called snapshots, which can be really useful, but I just want to give kind of a little warning towards using these. So in a snapshot test, we can mount a component and expect it matches a snapshot. When we do that, what will happen is it will dump into a separate file a snapshot, noting what the component did at that point in time. There's a problem here, though, because snapshots are quite big. They can get quite large if they're big components. And you kind of stop caring about them and think, oh, snapshot is probably fine. And because they're in a separate file, you will never look at them, ever. And so you don't really know what contents are in there. This is proved by a test. This is a genuine test I found in our code base that I'd written a few months ago. I had this big component. It took lots of configuration details. I snapshotted it to make sure it did the right thing. I then looked at the snapshot a few weeks ago. And I found this. The checkout component renders the card form correctly, null. This was not correct, and it causes a bit of pain. One of the issues with snapshots is that they're really big, and they go in external files. A really nice way to get around this, if this is going to play, it's not going to play if I press that. Yeah, it's going to play. Notice I've got to match inline snapshot here. Then when I run the test, if you look at the code up there, it then puts a snapshot in the file for me. So this gets rid of one of the problems with snapshots, because rather than being hidden away from you, they're right there, front and center. And again, I don't know what font that is. Cool. So that's me. I'm really sorry I've gone over time. Again, Advanced React will get you a discount on the 2 courses I have. Another shameless plug. I will upload the slides on SpeakerDeck in a bit. I've got so many plugs. Kent, the aforementioned Kent C. Dodds. This is my living room, by the way. There's the jumper I failed to put away before the talk on the floor. Kent and I did a YouTube talk all about testing. So if you've enjoyed this talk and you're not too bored of this voice, you might like that. And also, we're a startup in London, so we're hiring. If you'd like to come and work with me and write lots of JavaScript tests together, you can drop me an email, jack@thread.com. And if you have any questions, come and find me later or tweet Jack Franklin. And thank you very much for listening.